Hello and welcome everyone to York's Observatory's TeleTube, the online astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. TeleTube broadcasts on YouTube every Wednesday night at 7:30 p.m. local Toronto time. For any questions or comments you have over past shows, or if you have suggestions for future topics, please send us an email at observe@yorku.ca. You can also connect with us on Twitter or Instagram with the handle at York Observatory and Facebook at Alan I. Carswell Obs. I'm Matt, and I'll be one of your hosts today, along with Amin, Gagan, Obada, and Palvisha, broadcasting live from the Alan I. Carswell Observatory located in Toronto, Ontario, Canada. We've got a great presentation about concepts in ancient astronomy. Well, as I said before, welcome everyone. We get started with our main show, we want to give you a little update on what you can see this coming week. This week, especially tonight, we have the Pleiades cluster as well as M31 in our sky, commonly known as the Andromeda Galaxy, and the planet Mars is also visible to the naked eye. For tonight's presentation, constellations and clusters like the Pleiades as well as Orion, which is also visible, form an important part of ancient history. As a matter of fact, the Pleiades, also known as the Seven Sisters, is an open star cluster with a reflection nebula around it. Its name comes from the ancient Greek word plane, which means to sail, because the presence of the cluster in the sky was used to delimit the sailing season in the Mediterranean Sea. This has to do with the use of astronomy in navigation and the importance of heliacal rising, which will be mentioned later on during our presentation. They are also known as the Seven Sisters because their name, the Pleiades, was given to the seven daughters of Pleione in the Greek mythology. They are located in the constellation of Taurus, and they formed an important part of the development in mythology as well as astronomy as a science for several ancient civilizations around the world, like the Celts, the Egyptians, the Chinese, the Aztecs, ancient cultures in Australia as well as New Zealand, and as I said, all around the world. In the Paleolithic epoch, which lapsed from the year 33,000 to 10,000 before Common Era, the Pleiades and other constellations like Orion or Aldebaran were used for orientation in space for hunter-gatherers, which is shown in paintings found in caves such as La Tête du Lion in France, as well as the Cave of Lascaux. Another object that I mentioned will be in the sky, in the night sky tonight, is the Andromeda Galaxy, which is first described in the year 964 by Persian astronomer Abd al-Rahman al-Sufi as a nebulous mirror. Several star charts labeled it as the Little Cloud, and later on Charles Messier cataloged it as M31. And in 1917, it was an important factor on the island universes theory written by Herbert Curtis. So, there are a lot of amazing celestial objects that have marked our history as humans and have shaped our cultures and civilizations through the ages. And that's why, with the help of my co host today, we'll be able to learn more in detail how astronomy affected the ancient world and theories and concepts that were developed because of the stars. Go ahead, Amin.
Ancient astronomy dates back to thousands of years ago, with the start of the discovery period of humanity and the development of science and technology. Prehistoric carvings, paintings, and other creations have been found which depict star charts. One example of this is what Matt just mentioned about the Pleiades constellation, which can be observed on the nebula sky disk displayed in the left part of the screen. Another example is large structures which were built by some cultures, which use astronomical alignments for religious, social, and timekeeping purposes. The most famous of these, pictured here, is Stonehenge. Some of the first calendars used observations of the sun and the moon for their timekeeping, and these were important for agricultural societies who needed to know the seasons in order to manage their crops. The earliest written records ever found were about astronomical observations in Babylon, making astronomy the oldest known science. Early astronomers sought to find out information about the material world by studying astronomical objects and their positions and movements. Agriculture was a revolutionary development in human society. It allowed for people to settle down in cities instead of roaming around, and also to produce a surplus of food. This opened up new avenues of development in a large number of fields. If you can guarantee the production of food, then you have free time to develop science, technology, the arts, reading and writing, etc. Early cities became centers of innovation. Astronomy was very useful for ancient agriculture, and by extension for general development too. People noticed patterns in the movement of the sun and the stars, allowing for the prediction of the seasons. If you can predict the seasons, then you can plan when to plant crops, and you no longer need to rely on sporadic hunting and gathering. Astronomical techniques were thus critical for the development of early human societies. One special case was the Nile River. The ancient Egyptian civilization relied on the annual flooding of the Nile to grow their crops. Heliacal risings, which are the first visible appearances of stars at dawn, were useful for predicting this flooding. Ancient Egypt was built around the Nile River, and the river and its periodic flooding affected Egyptian culture and society deeply. Early calendars and constellation systems were developed later, which furthered the ability of people to predict the seasons. These calendars were invented separately in many different places in the ancient world. Before astronomy was used, early navigators used landmarks as a basis for exploration. You had to follow the coast and use natural features such as rocks. People eventually realized that astronomy was useful for navigation, and this allowed for boats to venture further out beyond the shore. Celestial navigation began as an ancient practice and involves angular measurements between the visible horizon and a celestial body such as the sun, the moon, a planet, or a star. It is possible to use these angular measurements to approximately locate your position on Earth. The sun was the most important of the aforementioned celestial objects. You may use the position of the sun and the shadows the sun creates to navigate as well as to keep time. The Islamic world used a magnetic compass, which uses the magnetic field of the Earth to find directions. They also used a tool called a kamal, which uses angles of stars and a piece of wood to determine latitude. Even better charts and compasses were developed later on, and the age of exploration was ignited. Ancient navigational techniques and subsequent innovations allowed for the expansion of empires and the discovery of new areas in the world. Naked eye astronomical observations and calculations by ancient civilizations were used in their societies, and this was seen in the structure of their places of worship, how they buried their dead, when they celebrated religious festivals, in telling what the future held, and how the reigns of their rulers were justified. In some cases, the sun and the moon, as well as planets and constellations, were deified. For example, in Egypt, the sun was the god Ra, the constellation of Orion was attributed to Osiris, the god of the afterlife, and the constellation Sirius was attributed to the goddess Isis. It is thought by some that the aforementioned Stonehenge was a gathering place for people to worship the sun and the moon. The stones were aligned with the movements of the sun and the moon. The Greeks believed that the Earth was stationary and that the universe was rotating. Earth was the center of the universe in this model. Later observations overturned this despite the clash of ideas with the Church. Most of the names of the stars, planets, and constellations of the Northern Hemisphere are inherited from the terminology of the Greeks. After the conquest of Alexander the Great, the Greek language became the main scholarly language of the world in Europe. References to stars and constellations appear in early Greek literature and texts. They also noted the existence of the planets. The term planet is actually derived from a Greek term meaning wanderer. Astronomy later became a branch of mathematics. Greek mathematicians discovered geometry and associated calculations, and they attempted to model celestial motions using geometry. The two-sphere model posited that the cosmos has two regions, a spherical Earth and a spherical heavenly realm centered on the Earth, which contains rotating spheres made of ether, which is a material that fills the heavens. Aristarchus of Samos was one of the best-known early proponents of the theory that the Sun is at the center of the solar system, not the Earth, but this was not well received at the time. In ancient Rome, Claudius Ptolemy compiled a massive work of astronomical knowledge, and he developed a way to predict the positions of the planets at different times. The Romans also developed a calendar that we currently use with some edits. Astrotheology became an important part in Mesopotamian mythology for the Sumerians. It also played an important role in the development of astronomy as a science. As a matter of fact, tablets dating back to the Old Babylonian period document the application of mathematics to the variation in the length of daylight over a solar year. The oldest significant astronomical text that we possess is Tablet 63 of the Enuma Anu Enlil, the Venus tablet of Amisaduqa, which lists the first and last visible risings of Venus over a period of about 21 years, and this is one of the earliest evidences that planets were known to rise and set periodically. Babylonian astronomy was adopted and further developed in Greek and Hellenistic astronomy. In India, in the 3rd millennium BCE, astronomy was used to create calendars as well. Vedanga Jyotisha, one of the oldest Indian astronomical texts, describes rules for tracking the motions of the sun and the moon for the purposes of ritual. Indian astronomers proposed a model where Earth is spinning on its axis. In the period after medieval times, Indian mathematicians created a heliocentric model of the solar system that was better at predicting motions than the European model at the time. In Egypt, the pyramids were created to align with the polar star, which was a different star than Polaris at the time. The great temple of Amun-Ra was aligned on the rising of the midwinter sun. Astronomy played a considerable part in religious matters for fixing the date of festivals and determining the hours of the night. Much of early Chinese astronomy was for the purpose of timekeeping. The Chinese used the lunisolar calendar, but because the cycles of the moon and the sun are different, astronomers often prepared new calendars and made observations for that purpose. Next up, Palvisha will discuss the Mesopotamian civilizations in more detail, as well as some interesting facts about the first heliocentric views that we know.
Thanks, Amin. As Amin said, I'm going to be taking us back in time to astronomy in Mesopotamia, Babylonia. Since the ruins of ancient Nineveh, present-day Iraq, were discovered in the middle of the 19th century, thousands of inscribed clay tablets have been discovered, some of which point to the existence of astronomy and mathematical techniques in this ancient world. The records of astronomy in Mesopotamia, Babylonia are different from other records of astronomy, as they need to be reconstructed from records and schematic drawings on these clay tablets. No astronomical instruments have been found. The study of astronomy and related astronomical observations were made by Babylonian temple astronomers. It was their occupation to study the heavens. Evidence for the influence of these Mesopotamian priests or astronomers on the practice of astronomy in Egypt, the Eastern Mediterranean, and the Indian subcontinent has been found. Astronomy in Babylonia was very different from astronomy in other periods of history. Astronomical observations were not considered very important, and most schematic drawings that were made were very straightforward. The ground they stood on was earth, and the sky was considered the lower boundary of the god's world. It also goes to note that, as far as we can tell, there was no true differentiation between astronomy and astrology for the Mesopotamians. The role of astronomy in society was mainly oriented around religion, and the stars were thought to be manifestations of gods. After the inscription of clay tablets was invented near the end of the 4000s BCE in southern Mesopotamia, tablets were used to inscribe lists of daily objects, animals, professions, and such. During the 3000s BCE, the first lists from the civilization containing the names of stars and constellations could be found. However, there was no definitive principle behind listing these celestial objects. It wasn't until the 2nd millennium BCE that texts mentioning astronomical phenomena could be found. These texts provided evidence of a belief that celestial objects are organized and that this organization can be explained and described. Evidence for their attempt to understand these objects and the organization of the skies is found in these clay tablets. An example of this is the 3 stars each text, written between 1500 to 1000 BCE. This text lists 3 constellations that should appear for each month of the year in Babylonia. There was one constellation for each month listed for each direction. One of the 3 constellations would be found in the north, one would be found near the equator, and one to the south. This text also stated that these constellations disappear after 6 months. Although this does not work in practice, as the appearance of constellations and stars depends on their declination, the 3 stars each text was an attempt to organize what was known about stars. The attempt to predict events in Babylonia was noticed for the first time in another text called the Molapin, which means plow star. Although it was first inscribed on tablets in the 7th century BCE, this text may go as far back as the 13th century BCE. It contains 6 lists of stars and constellations. Stars were organized by their position in the sky starting from the north, and constellations were listed with the dates at which they appeared in the sky, in an idealized calendar. Planets were also listed with approximate periods of visibility, and a table containing the length of the shadow of a stick at different times of the day and in different seasons was also included. At the end of the text, celestial omens are found, an attempt to predict celestial events. After the 7th century BCE, clay tablets contained even more information in attempts of understanding the skies. These tablets are now referred to as astronomical diaries. These diaries contained information about solar and lunar eclipses, planetary conjunctions, and time intervals between moonrise and moonset or sunrise and sunset. After 500 BCE, successful astronomical calculations by Babylonian astronomers can be found. An example was a tablet containing 17 steps to determine the dates of successive new moons between the years 104 BCE to 101 BCE. These calculations, although impressive, constituted a minority of the clay tablet diaries. Most inscriptions pertain to celestial omens. Some of these omens were the predictions of eclipses, which they were able to predict with fair accuracy. Eclipses were thought to be an evil omen against the king, and since they were now predictable, a substitute king would be appointed to bear the omen. The Babylonian calendar uses lunar months, which begin with the first visibility of the lunar crescent after the new moon, i.e., period of invisibility. The months on this calendar are 29 to 30 days long, so around as long as months in a year now. And there were 12 such months in a year for a total of 354 days. The Babylonian year was around 11 days shorter than the solar year, and a month was added when the calendar did not fit the year anymore, as they wanted seasonal activities to remain in their months without shifting. Early in Babylon, intercalations, which is the addition of a month in the year, were decided by the king, and so they were highly irregular. They became more predictable after 500 BCE, when a cycle of 19 years with 7 fixed intercalations were introduced. This happened during the reign of the king Nebuchadnezzar, when the Babylonians discovered that 235 lunar months were almost identical to 19 solar years, with a difference of 2 hours. So they were able to determine a fixed cycle of 19 years with 7 fixed intercalations. When it came to predicting eclipses, as mentioned above, the reason they could fairly accurately predict eclipses was due to the Saros cycle, a period of 223 synodic months, which is 18 years and 11.3 days, after which eclipses repeat themselves. Models of heliocentricity were not uncommon throughout history, so it would be incorrect to state that heliocentricity was first proposed by Copernicus, as there is evidence of ideas of a heliocentric model throughout ancient history. Such a model was also proposed in Mesopotamia, Babylonia. The Hellenistic Babylonian astronomer Seleucus of Seleucia adopted Aristarchus' heliocentric model and proved it, as per Plutarch's writings about him, in 150 BCE. According to Plutarch, Seleucus was the first to prove the heliocentric model through reasoning, but this cannot be known for sure, as there is no indication as to what arguments he used. However, Lucio Russo, an Italian physicist, proposes that Celius reasoned the heliocentric model through tides, and Bartel Leendert van der Waerden, a Dutch mathematician, proposes that Celius may have proven the heliocentric model by determining constants for the geometric model for heliocentricity and use these methods to calculate the position of planets. This again cannot be determined, as most of Celius's work has not survived. In addition to this, Seleucus is, as per Greek geographer Strabo, the first to assume that the universe is infinite. There are many cultures that have wondered and theorized about astronomy throughout history, so this cannot be said with absolute certainty. However, it is interesting to see how often these ideas come up throughout history. Next up, Obada will take you through astronomy in Egypt and Mesoamerica.
Thank you, Palvisha. Moving on, I'll be discussing some of the astronomical history in ancient Egypt and Mesoamerican civilizations. Astronomy in Egypt dates back to the 5th millennium BCE. The Egyptians were one of the first known civilizations to develop the 365-day, 12-month calendar. The calendar was not as accurate as the Gregorian calendar we use today, since it lost about a day every 4 years. The calendar was able to predict seasons to some extent, however it became more and more inaccurate the older it became. It wasn't until Ptolemy III's attempt to correct it with the addition of an extra day every leap year. The change was mostly resisted. Other than using the calendar for seasons, a 365-day calendar was crucial for predicting the annual Nile flood. Before the use of this calendar, Egyptians used direct astronomical observations of the constellations. The most well-known Egyptian structure is, of course, the Great Pyramids of Giza. It is well known that the pyramids were built as tombs for the pharaohs. However, their structure and alignment are of astronomical significance. In the image on the right, you can see the internal structure of one of the pyramids. The shafts leading outward point to the specific parts of the ancient Egyptian night sky. To be clear, the precession of Earth's poles causes the night sky to shift. From the time when the pyramids were built, around 3000 BCE, Thuban, a star in the Draco constellation, was the North Star at the time. So it is evident that the structure of the pyramid is specifically aligned to the North Star, the point where the heavens appear to turn. The other shafts might have served some spiritual purpose, but to this point it's still unknown the exact use of them. But it's clear that the Egyptians constructed it with the stars in mind. Another less known ancient Egyptian structure with astronomical significance is the Abu Simbel Temple, near the Egyptian town named Nubia. The temple was built by King Ramses II during the 19th dynasty of Egypt, around 13th century BCE. The temple, carved into the mountain, was constructed in such a way that its axes lined up with the rays of the sun to illuminate certain parts of the interior. Every February 21st and October 22nd, the light is able to enter and light up the statues at the back. Every February 21st and October 22nd, light is able to enter and light up the statues at the back of the temple, except for the statue of Ta, which is the god related to the realm of the dead. Although it is not clear yet, the dates are assumed to be the king's birthday and coronation day. The dates may also be inaccurate. Due to Earth's precession, the sun does not appear to be at the exact same location as the sky at the time it was built, causing the rays to misalign. Now, I'll be moving on to a much more different ancient civilization, the Aztecs. The Aztecs, a Mesoamerican culture whose presence was mostly around what we call today central Mexico. The Aztecs were able to develop a very sophisticated and intricate calendar used to predict astronomical events. The calendar essentially merges two different calendar cycles, the first being a 365-day agricultural calendar, and the second being a 260-day ritual calendar. The two cycles come together every 52 years, marking a new century. 365-day calendar is very obviously the solar calendar, which we use today, is able to accurately predict seasons, thus being coined as the agricultural calendar. Another Mesoamerican civilization that bears astronomical significance are the Mayans. The Maya calendar is very similar to the Aztec calendar. However, the Mayans kept much more astronomical observations and recorded and predicted many astronomical phenomena. The most interesting and significant predictions are perhaps for eclipses. They were able to track solar and lunar eclipses using a table in the Dresden Codex, one of the oldest Mesoamerican books dating back to the 11th or 12th century BCE. Now, Gagan will be talking about the history of astronomy in ancient Rome and Greece.
Thanks, Obada. Ancient Greece and Rome are pretty well known for their observations in astronomy, and some early Greek astronomers drew inspiration from Mesopotamian astronomy as well as the astronomy of some other cultures. Many of our constellation names today date back to Greek origins and are based in their mythology. In ancient Greece, astronomy was considered an important branch of mathematics and was therefore given a lot of thought. Even Plato was a proponent of further study and encouraged his students to pursue studies in astronomy. One of the main tasks for astronomers was to identify the objects in the night sky. There's a lot of speculation as to when the planets were first identified by Greek astronomers as Earth-like bodies rather than stars. Only 5 of the solar system's 7 other planets are visible with the naked eye: Mercury, Venus, Mars, Jupiter, and Saturn, but there have been records mentioning all of these. As Amin mentioned earlier, the term planet is derived from the Greek word for wanderer, alluding to the fact that these objects did not follow the same pattern of motion through the sky that stars did. Their odd patterns of motion were a big factor in distinguishing them from stars. Another question posed by astronomers at the time was how the universe was modeled. Most of the early astronomical predictions included either a geocentric model with the rest of the planets and stars orbiting around Earth, or a model that is neither geocentric or heliocentric and involves the Earth, Moon, and Sun, among other bodies, orbiting around an unknown object. One of the most well-known early geocentric models was the two-sphere model, which modeled the solar system as a spherical Earth surrounded by a spherical realm of ether meant to represent the sky above. This model has been described by Plato in his works on cosmology, Timaeus and the Republic, and Plato was also one of the earliest philosophers to suggest that the wandering motion of the planets could be explained by them revolving around Earth in spheres of ether. Eudoxus was one of the first mathematicians to attempt to mathematically describe the motion of the planets and tried to find periods of revolution and tilt of the axes for each of them. However, there were some issues with the Eudoxian model and difficulties it presented to predict the motion of the planets, as pointed out by several astronomers including Autolycus of Pitane in the 4th century BC. Following this, Apollonius and Hipparchus both introduced methods to more accurately predict the motions of the planets. Apollonius focused on how to account for the fact that planets change their speeds and distances, whereas Hipparchus was inspired by Babylonian astronomers and the accuracy to which they were able to predict planetary motion. He attempted to recreate the same results. Hipparchus is considered an especially important figure in ancient Greek astronomy owing to his work on cataloging stars in addition to his mathematical work on planetary models. Around the same time that Apollonius and Hipparchus were studying planetary motion in the two-sphere model, Aristarchus of Samos proposed a heliocentric planetary model, which is one of the earliest heliocentric models we have evidence of today. His model proposed that the Earth and the other planets revolved around the static sun, which was much larger than any of the planets. He even went so far as to assert that other stars in the sky were other fixed suns in the universe, and that the universe was much larger than originally believed. Compared to the early geocentric models, this theory was actually much closer to what we now know is true about our universe. While not considered especially outrageous, this hypothesis was still not very popular in the 3rd century BC when it was proposed, and most ancient Greek astronomers continued to support the geocentric model until much later. In the 2nd century AD, Ptolemy, a scholar at Alexandria in Egypt during the Roman Empire, published a comprehensive book on astronomy called the Almagest. This work went into detail about another adapted geocentric planetary model, as well as the mathematical ideas and observations that went into these theories, and he referenced many previous astronomers in his work. Ptolemy also proposed an order of the planets that stated that Earth was at the center of the system, orbited by the Moon, Mercury, Venus, the Sun, Mars, Jupiter, and Saturn in that order, followed by the fixed stars. This order was widely accepted until Copernicus revived the heliocentric model much later in the 1500s, which remains accepted today. I must note that the mathematicians and astronomers we mentioned earlier are by no means a comprehensive list of ancient astronomers and their accomplishments. Many ancient cultures for thousands of years were very interested in astronomy, and while not all records survive to this day, we can appreciate what we do know about their observations and ideas, and how they contributed to what we know about the universe. Well, everyone, you have been listening to the Alan I. Carswell Observatory's weekly TeleTube broadcast, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. The hosts this evening have been Matt, Amin, Palvisha, Obada, and myself, Gagan. Make sure to leave any comments or questions in the comments section of the video and talk to us in the chat right now. We will be around for the next 20 minutes to answer your questions. All of our programs are free, but if you would like to make a donation, please see our website at observatory.info.yorku.ca. You can always connect with us on Twitter and Instagram with the handle @York Observatory, and check out our website for show notes, content, updates, and contact info at observatory.info.yorku.ca. Thanks for tuning in, clear skies, and have a good night.